Hey guys, this will be the quadratic test review. I will be going over all the questions, including the last question with the word problem. So let's get started. So number 1 through number 6 is about solving quadratics, and it says that you can use any of the three methods that you would like. So for the first one, 10x squared minus 26x equals negative 12. Well, first what I would do is I would add the 12 on both sides like this. And then what I would get is 10x squared minus 26x plus 12 is equal to 0. And I noticed that everything can be divided by 2 on both sides. So then I will be ending up getting this. And then from here, I will try first the AC method to factor. So AC is 5 times 6, which becomes 30. And the two numbers that multiplies to give you positive 30 but adds to give you negative 13, because that's what we're looking for, is going to be negative 3 and negative 10. So then how would I be able to arrange these? 5x squared minus 10x minus 3x plus 6 equals 0. And as you can see, these middle two terms goes back to negative 13x. So then I can group these two together. And then I factor out the 5x out. So it will become like this. I group these two together and factor negative 3 out. And it will become like this. And therefore my factor would be this. And now keep this in mind that this is still equal to 0 like from here. So you will have to solve for the 0 separately by setting these 2 equal to 0. Then you will see that x equals 3 over 5 and that x equals to 2. Number 2. X squared equals 11x minus 28. Again, I'm going to move everything to one side. So I'm going to get x squared minus 11x plus 28 equals 0. The reason is that I will have to subtract 11x on both sides, and I'll have to add 28 on both sides to be able to cancel these guys out. Now from here, again, it's a very simple factoring. You can tell that it's going to be 28 AC, because AC is going to be 28 times 1 right here. But the two numbers that multiplies to give you 28 but adds to give you negative 11 is going to be negative 4 and negative 7. So I'm going to group these two together. Negative 4x minus 7x plus 28. And then x minus, I'm going to factor out the x first from both here and here. So I'm going to get x minus 4. And from these two, I can factor out minus 7 and get x minus 4. So my factor is x minus 7. X minus 4 is equal to 0. Please don't forget that I'm going to set each of these equal to 0 and get 7 and 4. Number 3 says 6k squared minus 42k plus 72 is equal to 0. Now from here, I'm going to divide everything away by 6. K squared minus 7k plus 12 is equal to 0. Again, this is factorable. For 12, the two factors that multiplies to give you 12 but adds to give you negative 7 is going to be 3 and 4. So I'm going to get k minus 3, k minus 4, and then I'm going to get k equals 3, and k is equal to 4. So I did go a little bit fast, but you can still use the AC method, and you can still get the question right. And let's try number 4. 6k squared plus 2k plus 9 equals negative 3. Now I'll add 3 on both sides. So you get, that's a 3, to get 0. And see, notice how that everything can be divided by 2 on both sides. 3k squared plus k plus 6 is equal to 0. Now here, I can try the AC method, which becomes 18. But there are no two factors that will add to give you positive 1 right here. Therefore, I'm not going to be able to do factoring at all for this case. I have to resort to either quadratic formula or complete the square. Now, it's up to you to decide whichever you would like to do, but I would prefer to do complete quadratic formula. So quadratic formula for this would be negative 1 plus and minus 1 squared minus 4 times 3 times 6 all over 2 times 3. Then it becomes 1 minus 12 times 6, which is 72 over 6. So my equation, or my solution, would look like that. And please say that x is equal to that solution. Now, just for the sake of people who wants to solve by using completing the square, I'm going to show you how to do that as well. So from here, I'm going to divide everything by 3 first. Move this to the other side. And then I'm going to give myself a little space here. And then is equal to negative 2 and give myself a little space here. So what am I really adding to the red line? 1/3, half it, which means same thing as saying 1/2 times 1/2 times 1/3, which gives you 1/6. Now, if I were to square that, it becomes 1/36. So that's the number I'm going to be adding to both here and here. Afterwards, the factor for this one is going to be k plus 1/6 squared is equal to negative 72/36, because that's what negative 2 is going to turn out to be with the common denominator of 36. And when you add these two together, it becomes negative 71/36 is equal to k plus 1/6 squared. Square root both sides to get rid of this. K plus 1/6 is equal to square root of negative 71/36. There's a plus and minus in the front, please don't forget that. Subtract 1/6 on both sides, and your final answer will be negative 1/6 plus and minus the square root of negative 71/36. That's going to make that a little bit more negative. And as you can see, this number and this number is going to be the exact same thing. This is going to be a 6, so negative 1/6 plus and minus the square root of negative 71. I drew that a little longer. Over 6, so this is a common denominator, so I can combine those two together and get that. And look at that. They are two exact same things. Okay? That's number 4. Number 5. 3x squared minus 6x minus 23 is equal to 0. Now again, 23 is what we call a prime number, so there's no two factors that multiplies to give you 23 other than 1 and 23. And if we use these two, there's really no way for us to get 6, even with the AC method combined. I mean, that's going to give you a 69, negative 69, and I don't know if there's any two numbers that multiplies to give you that. There is 3 and 23, but that's pretty much it. 1 and 69. So all of these factoring method is not going to work. So I have to resort to either completing the square quadratic formula. I'm just going to use quadratic formula here. Actually, it seems like complete the square might be easier. And how do I figure that? Well, if I divide everything by 3 here from here, you see how I get x squared minus 2x minus 23 over 3? Yes, there's really, ugly fraction there, but the b value is pretty easy to use. So when I do my addition, it's not going to be as bad. So I'm just going to do my completing the square here by moving this 23 over 3 onto the other side by adding them. And now the number that I have to add is half b squared. Half b is negative 1, squared is 1, so I'm going to add 1 to both of these guys. And look at that, x minus 1 squared, because that's what this becomes factor. And this becomes 23 over 3 plus 3 over 3. That becomes 26 over 3. Square root both sides. X minus 1 is equal to plus and minus the square root of 26 over 3. So my final answer is 1 plus and minus the square root of 26 over 3. Okay. Alright, so number 6. Let's do number 6. Number 6 says 10x squared minus 9x plus 6 is equal to 0. Now, are there two factors, AC, which is going to be 60, or are there two factors that adds to give you negative 9? Well, there's 2, 30, 4, 15, 3, 20, 6, and 10. Looks like none of these guys is going to work. So don't expect that tomorrow's test will always be factorable. So here I also have to resort to either quadratic formula or complete the square. Now, why am I going to use quadratic formula for this case? Well, if I divide everything away by 10, I'm going to get something like this. And these are really two fractions that I really don't want to deal with. Even though these are quite generally really relatively large numbers, I am still going to use my quadratic formula. So negative b plus and minus the square root of b squared minus 4 times 6 times 10 all over 2 times 10. So that's going to be 9 plus and minus the square root of 81 minus 240 over 20. So it's going to be 9 plus and minus the square root of negative 159 over 20. And that will be my final answer, x. Okay, so now after that's done, let's take a look at the graphing. For the graphing, what I'm going to ask you to do is do all of the following: axis of symmetry, vertex, domain, range, x-intercepts, and y-intercepts. So for the first one, it seems pretty simple. X squared minus 2x minus 3. I mean, you can factor that right away. It's pretty obvious. It's going to be x minus 3 times x plus 1. So my 2x-intercept is at x equals 3 and x equals negative 1. So for x-intercept, please write 3, 0 and negative 1, 0. And afterwards, what I can do is I can take a look at this equation and go, look at that, that's my y-intercept. Y-intercept is automatically given to me at 0, negative 3. Now, another thing that we might have to get is the vertex. The vertex, remember, always happens in the middle of these two x-intercepts. The middle value is always one of the x values, add with another x value, divide by 2. So that's 2 over 2, which is equal to 1. And even if you count from negative 1, 0, 1, 2, 3, you would see that it's exactly the middle between 3 and negative 1. So the vertex coordinate would be at 1. Now how do I find the y value? Plug it in. F of 1 is equal to 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 equals negative 4. So I have my vertex. The other thing I would need is an axis of symmetry. The axis of symmetry would always be labeled at x equals 1, or the template for axis of symmetry will be x equals to something. And this something is the same value as the x coordinate of the vertex. So after that's done, we have to talk about domain and range. Now to talk about domain and range, you really want to first graph this. 1, negative 4 is my vertex. 0, negative 3. There's a y-intercept. There's an x-intercept at negative 1, 0, and there's a 3, 0. So as you can see, if I plot these, it looks something like that. So as you can see here, domain, I always told you in the class, is going to be all reals. If you're wondering what this is, that's symbol for all reals. The range here would be from negative 4 and upwards, because all the values are present above negative 4. So you say y is greater than or equal to negative 4 because all the values is up here, which means it's greater. Okay, so number 2, f of x is equal to negative 4x squared plus 8. Now right away, I know my y-intercept is at 0, 8 because of this number. And if you plug in 0 for x, you will get the same result. Negative 4, I can factor that out and get this. Whoa, I made a mistake. That's supposed to be a 2. And if I were to set this equal to 0, what I would get is that I would get those two x-intercepts. Now here, I can just divide both sides by negative 4 and cancel these out. X squared minus 2 equals 0. X squared is equal to positive 2. So x will equal plus and minus root 2. Now during the test, I told you that you will be able to use your calculator, scientific calculator. So x-intercept would be, I would write it as negative root 2 over 0, 0, and positive root 2, 0, which is same thing as saying 1.414, 0, and negative 1.414, 0. So I've identified those two. Now let's talk about the vertex, or the axis of symmetry. Now remember, because the two x values are happening exactly the same amount away, that's symmetrical, negative root 2 and 2, the axis of symmetry in the middle has to be 0. So x equals 0. And the vertex will happen at 0, but that means I just have to plug it in to see where it's going to be. But it does turn out that if I plug in 0, it's the same thing as the y-intercept, so the y-intercept and the vertex is exactly the same. So I'm going to plot at negative root 2, which is negative 1.414, and positive root 2, 1.414. And then the y-intercept, or the vertex, will be at 8. So, and it's an upside down shape like that. Because, take a look at the a value, it's concave down. Domain, again, all real numbers. Range, it's the highest point that it reaches, which is 8, and everything below. So you would say y is less than or equal to 8, because it's got to be less than. It's got to go below. Number 3. F of x is equal to 1 over 4 x minus 1 squared minus 4. Now the good part about this is that this is in a vertex form. So vertex is right away 1, negative 4. Now another thing that they tell me is that this here needs to have an x-intercept and a y-intercept. Now not necessarily for x-intercept, but y-intercept is always occurring. So to do that, I need to get this in a standard form like we did for question 1 and 2. So I'm going to FOIL this. I FOIL always what's inside the parentheses, which will give you this. Then I'm going to FOIL it out. And as you can see, it's going to be plus 1/4 minus 4, which gives you 1 over 4 minus 16 over 4. Same thing as saying negative 15 over 4. That's not a 6, by the way, that's a 4. So this is 15, negative 15 over 4. So then I know what my y-intercept is, 0, negative 15 over 4, or approximately 3.75 negative. Now let's talk about the x-intercepts. The x-intercept has to be when I set this equation equal to 0. However, you can also solve for the 0 up here because it's already in what we call a completed square form. You can add the 4 on both sides, and then you can multiply both sides by 4, and then you can square root them, and then you will be able to find, that's x minus 1 by the way, and then you'll be able to find that I can add the 1 to both sides, so that x equals positive 1 plus and minus 4, which is 5 and negative 3. So aside from getting this, my two x-intercepts that I get would be 5, 0 and negative 3, 0. So in order to graph this, I go 1, 2, 3, 4, 5, 1, 2, 3, and those two are my x-intercepts. And lo and behold, if I take those 5 and negative 3 and add them and divide by 2, I get a 1, because that's 2 over 2, which is 1. Now, that axis of symmetry has to be the same x-coordinate as the vertex, in which it does. So I'll write axis of symmetry is x equals to 1. And afterwards, I plot a vertex as 1, negative 4, and then I connect the dots. Please plot more couple points here and here. I'm just giving you a rough sketch after you have completed that. So that was number 3. Let's talk about number 4. Number 4 is pretty much the same thing. And afterwards, what happens is that vertex is given to us as that, because always switch sign inside the parentheses. Then the y-intercept. Remember, you would have to FOIL this. If you FOIL x plus 1 squared, you will end up getting something like that. Attach all the other terms, well, the squared is not going because you FOILed it, minus 5 over 2. Now, you're going to distribute the 1/2 to each of these terms, and you get negative 1/2 x squared, minus x, minus 1/2, minus 5 over 2, this comes down. This put together, minus 6 over 2, becomes minus 3 at the end. So these two just comes down, negative 1/2 x squared minus x. So the y-intercept is pretty okay. I mean, it's at 0, negative 3. Oh, by the way, I think we forgot to do domain and range for the previous question. Domain is all reals, and range would be from here upwards. So y is greater than or equal to negative 4. Okay, so here, y-intercept is 0, negative 3. Let's talk about the x-intercepts. And I'm going to start from using here, which I'm going to set this equal to 0. Now the problem is I don't really want to deal with this negative 1/2, so I'm just going to multiply both sides by 2 or negative 2 instead. See, what happens is the other side don't change at all, but the left side changes dramatically. It becomes x squared plus 2x plus 6, because I must distribute them, right? Now in here, it doesn't seem like I can factor anything that multiplies to 6 but adds to give you a positive 2. So I just have to then resort to quadratic formula or completing the square. So completing the square means I can just go back up to here, whatever they had before, and then just use it to my advantage. Negative 1/2 x plus 1 squared minus 5 over 2 is equal to 0. Add the 5 over 2 on both sides. Then you get negative 1/2 times x plus 1 squared is equal to 5 over 2. Then you will multiply both by negative 2 here as well as here. Then these two will cancel out. This becomes negative 5 is equal to x plus 1 squared. And then square rooting both sides. Already you should know that something is a little off. You have a square root of a negative 5. This is impossible, which means it's not possible for you to plot this. So even though you have what we call an x-intercept figuratively solved out by using algebra, you would not say that the x-intercept is an imaginary. So you would say for x-intercepts, does not exist or DNE. So then how would the graph of this look like? I have a graph, I have a vertex as negative 1, negative 2.5. Then the y-intercept is in 0, negative 3. That means the one that's right after that, because this line has to be symmetrical, this x value will give you y value as the same level as your y-intercept. And maybe I will have to plug in more couple points. Let's do f of 1 into this equation. That means 1 squared plus 2 plus 6, which gives me a 9. Yet, however, the reason why this is going to be wrong is because there is no negative sign here. You always want to plug this function back into the original form, which is f of x is equal to negative 1/2 x plus 1 inside the parentheses, x plus 1 squared plus, minus 5 over 2. Then I'm going to plug in 1 into my x. Then it's going to be negative 1/2 times 2 squared minus 5 over 2. Then this becomes 4. 4 times negative 1/2 becomes negative 2. Negative 2 minus 5 over 2 will become negative 9 over 2, which is approximately negative 4.5. So here, I'm going to go down to negative 4.5, and you're going to plot the point right here. And as you can see, the graph will look something like this. You do need to have extra points down here for you to be able to graph this precisely. Next question, number 5. Number 5 is going to be negative 5 times x minus 1, x plus 1. Now, I gave you 2 of each kind. The first 2 was what we call the standard form. The second 2 were the vertex form. And the last one is going to be called the factor form. Now, why is called factor? Well, why are the factor form important? Well, because they give you zeros right away, or called the X-intercepts. Is at 1, 0 and negative 1, 0 for this one. How did I get that? X minus 1 equals 0, x plus 1 is equal to 0. Imagine if this was set equal to 0, which I know it's not because it's supposed to set equal to f of x. But when f of x, the y value becomes y, which tells you the coordinates that y is 0 for these two. That's why you can solve for these x zeros just by plugging in y as 0 and then getting this equation. So you have those two zeros. So I can graph this pretty easily at negative 1 and positive 1. Now it's time for you to find the vertex. But we already have discussed that the vertex is halfway between the zeros, which means the vertex would happen at x equals 1, or that it's going to become your axis of symmetry. Now for the previous one, I don't think I also did an axis of symmetry, but the axis of symmetry is labeled for you here, saying that x equals negative 1. All I did was use my vertex to the advantage and saw that the vertex x coordinate was at negative 1, so you say x equals negative 1 for your axis of symmetry. So here, it's the same situation. You're going to have it at x equals 0 because it's symmetrical about the line x equals 0. Then afterwards, we need to find the vertex. To find the vertex, well, we already found out that the x coordinate of the vertex is 0, so why not just plug it in? Negative 5 times, well, it's negative 5 times 0 minus 1, 0 plus 1 is equal to 0. Or actually, it's not equal to 0 anymore. All I'm doing is trying to solve for the y value of the x value when it's equal to 1, right? Negative 5 times negative 1 times positive 1, which becomes 5. So if it becomes 5, that means that it's 1, 2, 3, 4, 5, 0, 5, and then it's going to be an upside down shape like this because, look at the a value. It's negative 5, right? Which means it's concave down, so everything seems to make sense. Domain, let's talk about domain, all real numbers. I keep on writing this separate, but you can just write this for all reals. Range is just going to be from 4, and the y value has to be less. So y is less than or equal to 4, because this is the highest value it reaches, and everything goes down from there. So y has to be less than that. Let's do the last graphing questions before we move on to the word problem here. So the last problem here says 2 times x minus 3 times x plus 2 is equal to f of x. The two x-intercepts, you should probably know it's 3, 0 and negative 2, 0. So draw your coordinates, 1, 2, 3, negative 2. So the halfway through is your vertex, which means it's 3 plus negative 2 divided by 2 becomes 1 divided by 2. So actually the x coordinate of the vertex happens at 1, 2, or that's also your axis of symmetry when you label it as x equals 1/2. Then what I'm going to do is I'm going to take this 1/2 and plug it in. 2 times 1/2 minus 3, 1/2 plus 2 becomes f of x. Now, this might be a lot of work to do, but if you do it, then you get the correct vertex. This becomes negative 5 over 2. This becomes 5 over 2, and it's 2 times all of this. All of these 5s that might seem weird, but as long as it's a weird number, then just remember it as a 5. These two multiplied together will give you negative 25 over 4 times 2, which gives you negative 25 over 2, because these two can cancel out, 2 to 1 ratio. So negative 25 over 2 is approximately 12.5-ish. So if I go down all the way, 5, 6, 7, 8, 9, 10, 11, 12, 11.5 will be halfway between 12 and 13, or negative 12 and 13. So it would look very narrow like this. Now, notice how I didn't have any points here. You must try out some of these points. For me, I can sketch pretty easily, but make points, plug points. So get like f of 1, because you want to find out what f of 2. Tell me what f of 2 is. Tell me what f of 3 is. Tell me what f of negative 1 is. Tell me what f of negative 4 is. Get those extra values, even though it might seem annoying to do, and if you're running low on time, then you really can't afford this luxury, but you really want to test to see if your graph looks accurate or not. You need a lot of testing points. Okay, so let's do the last problem. Mr. Kim shot the basketball with a vertex of 5, 10 and a y-intercept of negative 15, which means this coordinate can be translated as 0, negative 15. Now we know the vertex form is this. And so if I plug in the vertex form, it's going to be a times x minus 5 squared plus 10. This is my testing point. So I'm going to plug in negative 15 for my y times a times x minus 0 minus 5 squared plus 10. This becomes 25. 25a plus 10 equals negative 15. Subtract negative 10, or subtract 10. Negative 25 equals 25a. So a equals negative 1. So once I find out that, then my function is simply just the negative 1 plugged in into your original equation, which was x minus 5 squared plus 10. This one, with the a attached. That's your solution to the first part. The second part is that Steph Curry shot the basketball with twice the height of Mr. Kim's maximum height. So the maximum height reaches when it reaches the vertex. We already have a vertex form, and this tells you your y-coordinate or your height. Because the height is 10 for Mr. Kim, for Steph Curry, then it has to be 20 because he has to double it. The last one is if basket is located at 10, 7. Would it go through using Mr. Kim's trajectory? Well, since we have the equation, we can just verify whether that point is part of it or not by simply plugging in. 7 is going to be y, negative 1 times 10 minus 5 squared plus 10. This becomes 25 again, but 25 times negative 1 plus 10 equals 7. This becomes negative 25 plus 10 equals 7. This becomes negative 15 equals 7. Now you see how it doesn't make sense, right? Therefore, the ball will not go in. If the ball traveled in that trajectory and made the shot at 10, 7, by plugging this into the equation, we should be able to get it equal to each other. So if it ended up being 7 equals to 7, then you would say, yeah, it's part of the graph, which means the trajectory hits that point. So this trajectory hits wherever that basketball is, it hits that point, and therefore it's going to be a solution. So that's it for the review. Any other questions you may have, you may address it to Google Classroom, to my email address, and make sure that you study hard for the test tomorrow. Thank you and have a good day.